Welcome. We're looking in Chapter 8, Standardizing Scores and Normal Distributions. This is the final unit we're going to talk about during this trimester. And by the end of today, or during the end of this presentation, we want you to be able to understand what a standardized score measure is, how you can calculate it, and then recognize when you can use it to compare values. It's a very, very significant tool to be used in statistics. Okay, so we're going to start taking a look at fantasy sports. So what are fantasy sports, right? So fantasy sports is where the owners of the league draft teams of actual players, and then the real life statistics are used, right, from their performances, right, to look at your fantasy team. They score points that way. So in fantasy baseball, each owner, right, combines the statistics of the players on his or her team using variables such as batting average, home runs for hitters, wins, and strikeouts for pitchers. You can get into crazy leagues that have an insane number of variables that they use. Okay, and then each team is then ranked according to the total point value that they earn when all those variables are added up. So how do we determine which players we should draft? Okay, so to do this, right, we want to look at ones who have the highest value. So how do we figure out this value when there are different scales? The number of strikeouts versus the number of wins, right? Wins, you're not going to have nearly as many for a pitcher when you're looking as compared to their strikeouts. Or for hitters, their hits should be way more than, their home runs and whatnot. So we have to look at a way that we can standardize that. So to do that, we're going to look at 2009. Ichiro for the Mariners batted .352, and Adam Dunn for the Nationals hit 38 home runs, which were both outstanding performances, but in the world of this fantasy baseball, which one of them was better? Okay, so we need to standardize this. So we need to look at how can we compare their performances to everybody else's performances in the league to see which one is better. So we had to do that, right? We need to get them all on the same scale. Okay, so this is how we're going to do this. Okay, we're going to standardize their scores. But first, I want you to take just a quick look. Okay, this is the total batting average for all the different players who had over 300 at-bats. And you can see Ichiro's way over here. Only one guy hit better than Ichiro in 2009. At the same time, Adam Dunn is up here at 38. So there were a handful of guys who hit more than him. But he's still pretty far up there. Okay, he's this red dot. So it's that individual player compared to the entire league. So to do that, to try and standardize that score, we want to look at it comparatively, right? So the average batter hit 270. So if we take Ichiro's batting average of 352 and we subtract that 270, we get that he was 82 points above the average. Okay, on the flip side, the average number of home runs for a player in 2009, it was 15.3. So if we take Adam Dunn's home run total of 38, right, subtract it from that, we get that he was 22.7 home runs above average. Well, does that mean that Dunn's just better because his is 22.7 above, whereas Ichiro's is only 0.082 above? Well, that doesn't really work, right? Because batting average is always less than 1. And, the home runs hit is going to be a whole number, right? 0 or greater. So we really have to standardize this. Okay, so we're going to look at it in comparison. And the way that we do, okay, is something called a z-score. Okay, so to be able to do this, okay, we have to look at it in terms of the standard deviation. Okay, so we're going to take the standard deviation of the batting average first, right? Which I'm not going to make you calculate. We're going to give it to you. It's 0.029. Okay, and his batting average was 0.082 above the mean. So if we take the 0.082, divide it by 0.029, he was 2.83 standard deviations above the mean. Okay, on the flip side, Adam Dunn, his standard deviation, right, the standard deviation was 9.9. His was 22.7 above that mean. So if you do that 22.7 and divide it by 9.9, you get that that's 2.29 standard deviations above the mean. So now we're on the same scale. How many standard deviations above the mean are they? So now we can compare them. Ichiro's was 2.83, Dunn's was 2.29, Therefore, right, Ichiro's performance was actually better. His was further above the mean. His was more outside of the normal. Okay, so to actually formalize that, okay, in a formula, okay, we want to look at that z-score. And the way we do it is we take the performance minus the mean and then divide it by the standard deviation. Okay, so if a z-score is positive, that means that that performance was above the mean. And when a z-score is negative, that means the performance is below the mean. So then you ask yourself, well, when would a negative z-score actually be a good thing? Oh man, when would that be a good thing? Well, I can think of a couple. Okay, the first one is, right, a quarterback's interception. Right? If a quarterback has less interceptions than the average, right, he's going to have a negative z-score, but that's a good thing, right? Because you don't want your quarterback to throw a bunch of interceptions. On the same line, right, a basketball player, when looking at turnovers, if they have less turnovers than the average player in the league, then they're going to have a negative, right, turnover z-score, and that would be a good thing. So let's look at a hypothetical situation. Okay, let's say that Mr. Moore, that's right, good old me. Let's say I played high school football and happened to be just a great quarterback, okay? And I averaged a half an interception per game. So let's say that the average interception per game was 1. And let's say the standard deviation was 0.4, so 0.4. So if we're to calculate and interpret, right, my standardized score, right, for interceptions per game, I would have to take my performance minus the mean and divide it by the standard deviation. Well, my performance was 0.5. If you subtract that from 1, which was the mean, and divide it by that standard deviation of 0.4, right, you get a negative number because I was less than average. So then I have a negative 1.25 would be my z-score, right? But when we interpret that, we would say, right, that's good that I had a negative standard deviation because that means that I had, right, I was 1.25 standard deviations below the mean. So I threw significantly less interceptions than what the average quarterback did. Okay, so it's a good thing. Yay! Negatives are not always bad. Okay, now, what happens when you want to look at players across eras, right? Everybody always wants to talk about the greatest of all time, right? The GOAT, who's the greatest of all time. Well, one of the things you have to look at is how does that player compare to everybody else that they played with? Because if you just look at straight statistics, it can get skewed, none more, in my opinion, than in baseball when we look at the single season home run record. Okay, so Babe Ruth just destroyed the home run record in 1927, right? He hit 60 home runs. Okay, 3 times since then it was broke. 1961 by Roger Maris when he hit 61 home runs. Okay, and then the steroid era came. And in 1998, Mark McGwire broke it at 70. And in 2001, Barry Bonds broke it at 73. Now, if you really want to get technical, Sammy Sosa at one point had a lead in the Mark McGwire Sammy Sosa race. So technically he hit more. But at the end of the season, right, Mark McGwire still held the lead. So we're just going to look at those 4 seasons. Okay, so let's see, right, just because Barry Bonds hit the most, did he have the best performance when we look at it in terms of everyone else in the league? Okay, so to do that, right, there are lots of different ways, you can think about it, talk about it, who's the better player, how did ballparks change, how the dimensions change, how's the equipment change, how's the mound height change, all these other things that affect it, right? So we're going to, as I said earlier, right, we're going to look at it in comparison to all of the other players in the league in those particular years. So that way we can really standardize that score. Okay, where were they compared to everybody else in the league? So we went through and we got the mean, the standard, and the standard deviation for each year. So in 1927, the average baseball player hit 7.2 home runs with a standard deviation of 9.7. In 1961, it was 18.8 with a standard deviation of 13.4. In 1998, it was 20.7 for the average with a standard deviation of 12.7. And in 2001, it was a 21.4 with a standard deviation of 13.2. So if we go ahead and bring up, right, a z-score for each one of these, so we take their performance, so the 60, 61, 70, and 73, minus the mean, and then divide it by the standard deviation, okay, we get that Babe Ruth had a whopping 5.44 z-score. Okay, Roger Maris had a 3.15. Mark McGwire had a 3.88, and Barry Bonds had a 3.91. So as you'll learn more as we keep going, okay, anytime you're 3 or above, that's a really outstanding score, okay, just as long as the positive scores are the good thing, right? So, I mean, these are all super high, but Babe Ruth is just far and away, just way above everybody else. He's 1.5, over 1.5, right, standard deviations further out than anybody else. He was so much better at hitting home runs than anybody else who he played with and during his entire era. Okay, most people consider Babe Ruth the reason why the home run is considered such a powerful statistic and such an important and exciting part of the game of baseball. Okay, so this is just going to go through what we just talked about, right? Barry Bonds' name might be in the record book, but at the same time, when you're talking about relatively speaking, right, Babe Ruth had the greatest performance, right, in a single season for being the home run champ. Now, let's take a look back at fantasy, right, because we looked at Adam Dunn and then Ichiro Suzuki, right? When we looked at them, we looked at one single statistic, right? But that's not really fair because there are lots of statistics. So even in the most basic leagues, right, there are usually at least 5 factors that are looked at on offense. Okay, so those 5 factors are batting average, home runs, RBIs, stolen bases, and runs scored. Now, if you're in a particularly high level league, there's going to be a lot of other ones, okay? But we have to look at all of those values to get an idea of truly which one is better. So we want to standardize each single one of those scores and then add them all together. So again, to do this, you need standard deviation and mean because you have to take their performance, subtract the mean, divide by the standard deviation. Okay, if you do that with all of their statistics for batting average, home runs, RBIs, stolen bases, and runs, right, you can go through and look at each individual one here, right? You can pause it if you need to spend some time looking, right? But you see that the sum of Ichiro's is 4.39 and the sum of Dunn's is 3.79. Therefore, Ichiro, although not by much, overall has a higher value because he got a slightly higher score. Now, quick note, this only works with z-scores where above average is better, right? So if you're looking at strikeouts for hitters, that's not a good one. You'd have to subtract that from the z-score instead of adding it in. So you do have to be careful of that little nuance. So now, when would you consider something unusually high? When is it so big, right? So the 68, 95, 99.7 rule is what we use here. And it's kind of what I mentioned earlier. Okay, now this works best if they're roughly symmetrical, unimodal, and bell-shaped. So approximately 68% of all observations fall within 1 standard deviation, 95 within 2, and 99.7 within 3. So here's what that looks like in graphical form. So you can see, right, with the -1 to positive 168, so roughly 34% on either side, right, and then 98, then 99.7. So if you're outside of that 3 standard deviations, you're in the 0.3%, right, 0.3. So you get outside of 3 standard deviations and you are definitely in that area of it being an unusual performance, right? Now, if they're skewed or bimodal, doesn't work so well. Okay, earlier we talked about Emmitt Smith. Here we're going to look at Barry Sanders, in your homework tonight, you're going to look at Emmitt Smith. Here's looking at Barry Sanders, right? This was his career rushing totals from every game. You could see, right, a huge percentage of them fall within 1 standard deviation on each side. Almost all of them fall within 2 standard deviations on either side, and all of them fall within 3 standard deviations. So again, just a visual representation you can see. Okay, they fall, right, and this works for all data. That's one of the cool things about it when you standardize it out. It helps you to really see where that data falls. So hopefully you learned a lot. If you have questions, please make sure that you ask, and hopefully you're having a wonderful night. Thank you very much.